Learning Objective C wants us to state the domain, the ranges, and the asymptotes if the graphs have them. So the first thing I want to do is just review asymptote and discontinuity. Recall what an asymptote is. It's a line that a graph of the function y equals f of x approaches as the x value approaches some fixed value as x increases or decreases without bound. And it's typically going to be graphs that are some number over x or some number over x squared. Let's go back a few parent functions. Remember this parent function that we looked at here, f of x equals 1 over x. This does have two asymptotes to it. If we identify it, we talked about it earlier, this is one line it's approaching, and this is a second line it's approaching and getting close to. Now be careful, the equations of these lines, if you have to write it, this right here, a horizontal line, is crossing the y-axis at the number 0, therefore that's the equation. This vertical line here crosses the x-axis at the number 0, so that's the equation of that asymptote. Now this other graph is 1 over x squared. This also has two asymptotes. One is going to be right down here in the middle, and the other is going to be right here. Now it's a line it approaches but doesn't cross. So again, this vertical line crosses the x-axis at 0, so that's the equation of the vertical line. And this horizontal line crosses the y-axis at 0, therefore that's the equation of that asymptote. Now the other word is called discontinuity, and it's a point at which the graph of a function appears to jump. And what it is when you're drawing the graph, if at any point you have to lift up your pencil to continue to draw it, you just created a point of discontinuity. Well, if I draw this first graph here, on the blue end I'm drawing this downward. When I get to the other side, I had to lift my pencil up and continue to draw. So on that, there was a point of discontinuity. It happened when I hit the x value of 0. So when I got to this point, I had to lift my finger up, and my pencil got off the paper. So the point of discontinuity happened at the actual vertical asymptote, so when x was 0. Same thing with the second graph. As I'm drawing this one, here's the blue, I lift up my pencil when x was 0 to jump over across to continue to draw it. So here, again, this vertical asymptote actually created a point of discontinuity when x was 0. Basically, when you have a vertical asymptote, you have a point of discontinuity. Domain and range. Remember the domain, if they ask you what the domain is, that means what can the x values be. When they talk range, they want to know what the y values can be. It's alphabetical, x comes before y, as d comes before r. So let's talk about this first question here. They want to know of these 8 parent functions, which ones the domain does not include 0. So all you have to do for that is you travel on the x-axis and you wait till you don't see any graph activity. Basically, if there's a break at the number 0, means they couldn't put an answer in when x was 0. Well, when x is 0, we have a point. On the parabola, we have a point. Here we have a point. Here we do have a point when x is 0. I can put 0 into the square root of 0. Be careful, the square root of 0 does give me an answer of 0, so 0 actually is included in this graph. This right here, when there's 0, a vertical asymptote came up, so there is, the domain does not have 0 there, nor does this one have a domain of 0. Now be careful, the absolute value doesn't include 0. Can you find the absolute value of 0? Sure, it's 0, so that one is actually fine. This exponential growth one, at the number 0, were they able to have graph activity? Sure, it's right there. If you saw a break in the graph when x was 0, then you'd have an issue. So the two of them that do not have their domains including 0 would be graphs E and F. Okay, question B. Which of the graphs contain the origin? So to contain the origin means you have the point 0, 0 on your graph, so that one, this one here, and this one here. So what we're seeing, the ones that contain the origin are the top 4 and letter G. The other ones do not. Let's look at these parent functions again. List all the functions whose domain is not all real numbers. So on here, there are a few functions where you would say not all the x's are going to work. So when you look at that, we're going to notice, again, there's no break in this graph, no break, no break. These are fine. Now graph number 4, the square root, there's no break in it, but it doesn't start until here. There is no x activity in the negative x's. So for here, the domain of this, you would say it's not all the reals. What the domain is for this one, let's state it. Are the x's greater than or equal to 0? Again, graph 5 and 6, because we have those asymptotes, we do have issues. What is the domain for this? So let's state it. The domain on this one, we have, when we're in the negative x's, we have graph activity down here. In the positive x's, we have graph activity. It's just when we hit 0. So what I would say here is the domain is all the reals except the number 0. Similarly, this one in the negative x's, I have graph. In the positive x's, we have graph, but at 0, we don't. So the domain for this is going to be all reals except 0. This graph right here, there's no break in it. It's just fine. In this graph right here, there's no break in it. It's just fine. So graphs 1, 2, 3, 7, and 8, their domain is all reals. Okay, let's look at this one and try to eyeball the domain and the range this time. So starting with the domain, again, are the x's. So we're going to travel around the x's, and we see graph activity until right here we have to lift our pencil up. It looks like to me this asymptote happens here at x equals 2. Then the graph gets continued to be drawn. So the domain for this function, I would say, is all reals except the number 2. Now the range works just like the domain, but you don't travel along the x, you travel along the y. So as I go up the negative y's, I see graph activity, so there's answers in these negative y's. When I hit the y of 0, though, an asymptote just got dropped, so there I have an issue. Continue to travel on the positive y's. Well, I have graph activity over here when I have positive y values. So the range on this one are the y's, and that's going to be all reals except 0. Why we're here, let's go ahead and write the equation of those asymptotes. So this vertical asymptote hits at x equals 2. The horizontal is at y equals 0. Let's look at one more. So when we graphed this square root function here, we came up with a good window on the previous slide. Keep in mind this point right here is at 8, 5. So if we want to talk about the domain and range, I have 4 different choices here. What makes the most sense? Well, on the domain, there's no x activity until we hit the number 8. Well, does the number 8 work? If I put 8 minus 8 in here, I get 0, and I can take the square root of 0, so it does work at 8. So the x's at 8 start getting me the graph. So if you look at it from there, the x's are greater than or equal to 8, so it looks like it's going to be this option. Well, let's look at the range. If we travel on the y's, the negative y's, there's no graph yet. I don't get graph activity until I hit the y value here of 5. Now, does it include 5? Sure, it does include 5 because when I put 8 in here, it simplifies to the answer of 5. So it's 5 and everything higher. So based on that, letter A is the appropriate answer for what the domain and the range are. Let's look at one more. Here's a nice real-life example. We have Stephen here, who is 1.5 meters tall, dives off of a 3-meter springboard. An equation modeling his height in meters above the water in seconds is this equation here. So create a graph that would be helpful for it. Well, I just went into y equals, and I typed this graph right here. Zoom standard actually gave a decent window. Now, if you think about what this stands for, though, this is the time, and this is the height. So really, anything over here in quadrant 2 and 3, when time is negative, really doesn't make any sense. So technically, that's not a good part of the graph. And even this empty blank space here isn't really a good part of the graph. So to get a better window, I should probably just zoom in a little bit more on here. But we can answer the question about the domain and range for that. And you have to remember this. This is real life information now. If they had just given me this graph right here and said, what's the domain and range? I'm going to tell you, the domain would be all reals, okay? And the range would be whatever this y value is here and everything lower. But this is a real life example. So the real life example in terms of the time for the x's, well, when he jumps and starts his jump, the the stopwatch just started at time 0. So really, if you think about it, the x's are going to be anything from when he's standing on the board at time 0 all the way to when he jumps. By the way, once he crosses the x-axis, he technically is just inside the pool and he's in the water. So for us, the domain is not going to be all reals in this case for a real life example. It's going to be all the x's or all the times greater than or equal to 0. Now the range on this one, I would have to technically use my calculator though, because I need to find this maximum height. So remember, I would do second, calculate maximum height, left bound, right bound to find it. Well, on this one, I will tell you when I did it, there was something for the x, but the y value came in at 5.73. So the range for this, does it include the height of 5.73 meters? Sure, that is the maximum. So the range is the y's less than or equal to 5.73, and that would be the appropriate answer for that.